Hello, everyone. You are welcome to GMAETS 41's chemistry class. In our class today, we are going to look at how to write the correct chemical formula of a chemical compound. We are going to give attention to binary compounds, how they are formed. How do you write the correct chemical formula? We're going to give attention to trinary compounds, how they are formed, how to write their correct chemical formula. You would recall that in our previous class, I already taught you the concept of valency of elements and the concept of radicals and their valency. So I want to believe you have done your job before this class. Once again, we are still looking at the importance of valence electron, because all this whole idea actually comes from the concept of valence electron. I had already stated this time and again, which is why I said that as a science student, you don't joke with valence electrons. From that guide, there are so many things you can actually do in chemistry. So once again, welcome to this class. Once you join this class, give it a like. Share it, help somebody out there, invite someone to join the live class right away. And always remember to continue to share our video lessons. If you have done your job, your own work, which is very important from our previous class, by now you would know, or you would have learned the valencies of our first 20 elements at least. You know, in that last class, I remember that I eliminated maybe the valency of carbon, silicon, and the valency of, helium, neon, and argon, five of them. Then I told you to work on the valency of the rest 15, get them. All right. The reason I eliminated these 5 is because they are not much of our problems, and I told you their valency from that last class. Valency of carbon is 4, silicon is also 4. Valency of helium, neon, argon, right? Yeah, helium, neon, argon, their valency is 0. That's the combining power. The valency of radicals, I also gave them to you in our last class. So without wasting time, we're going to move on to how you can use this knowledge, to get to write correct chemical formula of compounds. I hope we are together, right? Now, what do we expect to learn at the end of this class? You'll get to know what binary compounds are. You'll get to know what trinary compounds are. You are going to learn about atomicities of elements in a compound. Are you getting me right? Now, I won't talk about molecules in this class. I won't. At the end of this class, perhaps before our next chemistry class next week, I am going to teach the concept of molecules, but that's going to be through our YouTube short or normal pre-recorded video. I've always told you, make use of the pre-recorded videos also on this platform and our playlist, so you don't miss out on anything. There are certain things I may not want to talk about in the live class. Atomicity. So without wasting time, we are going to define first what is atomicity before we move on to the concept of how to write the chemical formulae of compounds. All right, chemical formulae of compounds. So atomicity first place. What is the meaning of this term, atomicity? So I'm going to define it right away. Atomicity of an element in a compound or in a molecule is simply defined as the number of atoms of that element in that compound. Atomicity, simply defined as the number of atoms of an element in what? In a compound or in a molecule. So if I give you a compound now, go to a particular element in that compound, how many of its atoms do you have in that compound? Or if I give you a molecule, for example, oxygen molecule, chlorine molecule, nitrogen molecule, How many of the atoms of that element do you have in that molecule? So the number of atoms of an element in a molecule or in a compound is what we call atomicity. Have I passed the knowledge? Now you've listened to the grammar in terms of the definition. You know what it is now. Now, how do you actually get this atomicity? In a compound, atomicity is written as a subscript. In a compound, atomicity is written as what? A subscript. Subscript, just below that, below the atom of that element in the compound, just below it. On its right. On its right. So let us assume that I have a compound. I tell you that the compound is X sub A and Y sub B. So you have this atom of a particular element. You have this atom of another element. The atomicity is written below, subscript, just on the right of that atom of the element. So in this, sometimes the network interrupts a lot, okay? Would continue to be patient with you. Like I say, whenever we're experiencing network challenge, please get tough. Get tough. As a student, you don't easily give up. For being a student in that field of study, you are being trained to be tough. Am I communicating? So that by the time you graduate, you can be able to face the real world. Before somebody will say that I don't have a job, I was not given job by the government, by this or by that. Sometimes you don't need these bodies to actually provide you with a job. You can create it. That toughness that you have trained yourself with. All those years of your studies, you apply all of them now in real life. So let's get to business. I don't know if you followed up when I defined atomicity, but I told you it is simply the number of atoms of an element in a compound. And I told you that atomicity is written as a number just on the right-hand side of the atom of an element in a compound or in a molecule below. You write it as a subscript. I showed something like X subscript A and Y subscript B, where A and B are numbers. So I was actually going to talk about where you got this atomicity from, which is why you don't joke with that. You get atomicity from valency. You get atomicity from where I said valency. And you know that you get valency from what? Valence electrons. You get valency from what? Valence electrons. So you can see the relationship why you do not joke with valence electron. So let me just be crystal clear. Although this may not be funny to hear, but of course, whatever that is worth doing is worth doing well. Imagine I just finished the life GMAETS 41 Special Science College Student Progress Development Monitoring before coming on live now. Because I know that what I am doing is worth doing and I have to do it well. We have had about two classes on this valence electron stuff. This is part 3, as you can see. So to follow up very well, you need to understand the concept of part 1, the concept of part 2, and then now part 3. Because all these things are connected. Atomicity is connected to valency. The board is a bit blurry, right? This network. Okay. So like I said, atomicity is connected to valency. And valency is connected to valence electron. So all those ideas, you are expected to have them before this class. I've told you where you get atomicity from. Okay? Take note. Now, let us get to our business. I am going to give you a compound. I'll mention the name of the compound, and then we are going to write the correct chemical formula of that compound. The first one we are going to look at would be the compound called sodium chloride. Sodium chloride. Sodium chloride. This is a binary compound. How did I know that this is a binary compound? It contains 2 elements. It contains what? 2 elements. Right? Good. The 2 elements are sodium and chlorine. But you know, as a binary compound, what you do is you pronounce the first element fully. Then the second element, you pronounce the prefix, the beginning part of the name, and then the end part, the suffix, you change it to "ide." You change it to what? "ide." Now, from this name, sodium chloride, the elements present there are sodium and chlorine. Sodium and chlorine, these are the elements present. So how do we now write the correct chemical formula of sodium chloride? It's going to be a combination of sodium with the valency of sodium. Let me show you. This is the valency of sodium. By now, you should know that. Then combined with chlorine, the valency of chlorine is -1. So when they combine, this is what happens. They will interchange their valencies. Let me show you something now. Chlorine will give its valency to sodium, and the valency will be written as a subscript just on the right of that sodium below. Sodium will give its valency to chlorine, and the valency of that sodium will be written as subscript on the right of chlorine. Once this happens, the two elements will now combine. You write the metal first. You write that guy with positive sign first. That's the rule. So I'll write sodium. Okay. Now, the valency that chlorine gives to sodium is 1. This minus represents -1. So it's 1. Something like this. I'll still wipe it. Then you write the negative element. And the valency that sodium gave to chlorine is 1. That 1 will be written down like this. Yes. Na1Cl1. But remember that in the introductory part to this topic, I told you that if the atomicity is 1, you don't show it. Do you now observe that the atomicity is actually obtained from what? The valency. And you know that valency is obtained from valence electron. So let us wipe this, the 1, because if in a compound the atomicity is 1, you don't show that 1, you don't. Therefore, sodium chloride is written as NaCl. Therefore, the chemical formula of sodium chloride. Chemical formula of sodium chloride. Of sodium chloride is NaCl. NaCl. So if anybody tells you that sodium chloride is written as Na2Cl, the person is what? Wrong. The person is wrong. We are told that the chemical formula of sodium chloride is this. The person is wrong. If you are told that the chemical formula of sodium chloride is this, the person is wrong. You see, you want to respect this. This is how the correct chemical formula of sodium chloride is written. NaCl, nothing and nothing else. You don't touch the atomicity. Now let me tell you this. The atomicity of, assume you are balancing a chemical equation now. Let us assume you are balancing a chemical equation. You just have to write the correct chemical formula of the compounds there. When you are balancing, what you balance is the number of molecules. What you balance is the number of molecules. You don't touch the atomicity, because you are expected to be able to write the correct chemical formula of that compound. And if you write the correct chemical formula of a compound, automatically it means that the atomicity will be correct. So you don't touch it because it's not your mate. Am I communicating right? Now, this is the correct chemical formula of sodium chloride. Imagine that I now ask you to write the correct chemical formula of calcium chloride. Now, what would you do? If I tell you to write the correct chemical formula of calcium chloride, how will you write it? I know that many of you will fail it. Yes. Because if I tell somebody that sodium chloride is NaCl, and I said, okay, write calcium chloride. Write calcium chloride. Many will be tempted to go and write it in another way around. That another way around will be like they'll be guided by this sodium chloride to write calcium chloride, CaCl. Of course, this is wrong. Okay? This is not the correct chemical formula of calcium chloride. So let us find out the correct chemical formula of calcium chloride, number 2. Meanwhile, let me check the network situation, please, if we are still on. Okay. Violet, you are the best teacher. Thank you very much, Violet. I appreciate the commendation. All right. Thank you for connecting to the class, and make sure you always take your studies seriously. So I want to write correct chemical formula of calcium chloride. Calcium chloride. So you see, from the name, we can actually determine that the elements present are calcium and chlorine. Calcium chloride. Now, how do we get the correct chemical formula of calcium chloride? This is a binary compound. Binary compound contains 2 elements. So you have known what binary compounds are. Compounds that are made up of 2 what? Elements. And how do you pronounce that compound? Because all these things you need to know them. How do you pronounce the name of binary compound? Simply mention the first element written there, which is usually a metal, most cases. Pronounce that first element fully, the name. You can see, like in this case, Na sodium. Then the second element in that binary compound, pronounce the prefix chlor. So of chlorine. That ring, that INE will now change to IDE, ide, chloride. So if maybe in a binary compound you have oxygen as the second element, for example, that oxygen will change to oxide. If, let's say, you have sulfur as an element in a binary compound, and that sulfur is the second element, instead of sulfur, you pronounce the beginning sulf, and then the ending part will change to ide. These are the rules. So pronouncing binary compounds is very simple. You have to now know how to write the correct chemical formula. So we go. I'll write calcium. Always write the positive element first. And you know that the positive valence element is metal. Write it first. Here, calcium is the metal. I've taught you in part 1 of valence electrons, how to determine metals and non-metals. So calcium, what is the valency of calcium? You write it. You see, so we need valency. And then it is combining with chlorine. Valency of chlorine is -1 already, as we have it. When they combine, what will they do? They will interchange their valencies. So chlorine will give the valency to calcium as its atomicity. Then calcium will give its valency. Calcium will give its valency to chlorine as its atomicity. Then they will now combine. This network is just hanging, freezing me and the rest of them. Hello, sir. How are you? Prama Sakilapta Camp Mechanic Mother. All right. I hope I was able to pronounce that correctly. I am doing fine, and I hope you are also fine, right? You're welcome to join our class. You're welcome to join our class. Please, I will be grateful if you tell me about the network situation at your end. I hope the network is not troubling you too much. I hope you are following, okay? Please, this topic is very, very important, extremely. If you don't know how to write correct chemical formula of a compound, the truth is, there is nothing you are doing in chemistry. In fact, there is nothing you are looking for in science. The end of everything will just be a kind of trial and error method of learning. See this topic, how to write correct chemical formula of a compound, you need it absolutely. Okay? If you are writing chemistry exam and you want to write a compound, if you write the name of the compound in word, like sodium chloride now, your examiner will prefer you to write the chemical formula instead of writing the name in words without showing the chemical formula. So you can see how important that is. Let's move on. So when they combine, what is going to happen? You write the metal first, which is the negative element, the positive element. You write the metal first, which is the positive element. So if you write the metal first, which of course is the positive element, you have to indicate the atomicity. And the atomicity will be the valency obtained from the non-metal, from the negative element. The valency that chlorine gives to calcium here is 1 because the valency of chlorine is 1. And then you combine it with the negative element, which is chlorine. You write the atomicity of chlorine, which is the valency of calcium. Calcium is given 2 as valency to chlorine. So this is calcium chloride. You now see that the atomicity, the number of atoms of this element, calcium, in this compound, calcium chloride, the number of atoms of calcium is 1. And when the atomicity is 1, I told you we don't show it. So I'll wipe this off. I'll wipe it off. This is calcium chloride. This is calcium chloride. So do you see? Sodium chloride is this, NaCl. 1 atom. Now look at calcium chloride. Someone might feel like, if sodium chloride is NaCl, then calcium chloride should be CaCl. I remember I was teaching some students recently, and I had to expose them to this. And I told them that there is something I am expecting that almost all of them will say, which is going to be wrong, or which was going to be wrong. And eventually, they proved me right, because all of them failed this. Yes, all of them failed it. I wrote sodium chloride, that is the correct chemical formula, and then I told them to write calcium chloride, and they wrote CaCl. But of course, you won't blame this student fully. Most of you are also found wanting here. You are also a victim in things like this, because, like I said, with many years of teaching science subjects, especially in chemistry, I found out that many students have this challenge in writing correct chemical formula. Where it gets so messy is that some of us, as teachers, as educators, even in schools where we teach, because many schools will continue to complain of chemistry teachers. You see that the one they have, they don't even understand the way the person is teaching, likely because the person does not understand the subject, or the way the subject is being imparted is not really making good sense. Now, you see this topic. This is a topic that is learned from grade 10, to be specific. Grade 10. And it's very important. Everything we are dealing with under valence electrons, part 1, part 2, extremely important, because it falls under atomic structure. Once a student misses out here, it becomes a very huge problem for the student to withstand chemistry further. And that is why many students end up saying that they don't like chemistry. They don't understand it. But as a science student, of course, you have no choice. You have to like chemistry. You have to love it. Let me tell you something, like here in Nigeria, if a science student does not credit chemistry, the least you should get should be credit 6. And of course, when it comes to admission competition, to gain admission, you want to score very high. You should be aiming distinction, A1, B2, at least B3, so that your results will be competitive in gaining admission. So you have to love this subject. It's simple. And I'm going to help you. I'm going to guide you here at GMAT 41. If you have not subscribed, make sure you subscribe right now. If you have not subscribed to this channel right now, make sure you click on the subscription icon. After you subscribe, go ahead and then click on the notification bell. Turn it on. Once you click on it, a menu will pop up. Tap on all, so that anytime I come on live or I upload any video, you will be personally notified firsthand, okay, that class is ongoing now, or something has been uploaded for you to learn. So make sure you follow up with our classes, okay? Calcium chloride is not this. Take note, it's not. This is wrong. That you have sodium chloride to be this does not mean that calcium chloride will be this. If you check their valency, you get to know the correct chemical formula. If someone tells you that calcium chloride is written like this, it is wrong. Okay? If someone tells you that calcium chloride is written like this, it is wrong. So many times, this aspect, this part of chemistry is not usually well taught at this grade 10. Grade 10 in Nigeria is SS1. So take note, if you're a Nigerian student and you're in grade 10, you have the opportunity now to learn this thing for what it is meant to be, so that I don't end up complaining like other senior students and even some in advanced level university that would say they do not understand chemistry. This is very simple. Nothing is there. It's 1 + 1. So let us conclude, please, and then move on. No time. Therefore, chemical formula, the chemical formula of calcium chloride. Calcium chloride is CaCl2. Anything apart from this is wrong in terms of the atomicity. The atomicity here is 1 for calcium and 2 for chlorine. So if you look at the ratio of combination of calcium to chlorine in calcium chloride is 1:2. 1:what? 2. That is the ratio of combination. Because an examiner can ask you also, what is the mole ratio of calcium and chlorine in calcium chloride? What is the mole ratio of sodium and chlorine in sodium chloride? You know, you meet that when you are calculating empirical formula and molecular formula. You meet that concept of mole ratio. Are you following, right? So all these things, you do not joke with them. You do not joke with them. A lot of information from the concept of chemical formula. And like I said, getting to write correct chemical formula of a compound comes from where? Valency. And understanding valency comes from where? Valence electrons. So don't joke with that valence electron. Don't. We are moving on. Let me wipe this. Let's look at another compound. You know, all these guys are binary compounds. I've given them to you. Let's look at this compound number 3. We're going to look at magnesium. Magnesium oxide. Magnesium oxide, another binary compound. Another what? Binary compound. Magnesium is Mg and then oxide. Oh, oxygen. So these are the two elements that make up this binary compound. You can hear the name, magnesium oxide. So the negative element in that compound, in that binary compound, the ending part, the suffix is always changed to "ide." You pronounce the positive element fully. You pronounce it fully, like in this case, magnesium, that metal. Then the non-metal, in a binary compound, pronounce the prefix, the beginning, the end part of the name, the suffix, you change it to "ide." So you know how to do that now, which means if I give you something like NaBr, Br is bromine. So the name will now be what? Sodium bromide. Please, let's go. How do we get the correct chemical formula of magnesium oxide? So you go through valency. The valency of magnesium is 2+, +2. Then it's combining with oxygen. The valency of oxygen is -2. We've treated all of this in part 2. When they combine, they will interchange their valency. Please, I am not going to draw this again. And henceforth, in your notes, don't draw this line showing how they interchange their valency. This network seems to be disturbing much. This network seems to be disturbing much. And I guess, let's see. All right. Please, let's see what happens. Magnesium oxide. So we have this, and they are going to interchange their valence, like I said. Please do not draw this line that shows the way they interchange their valence again. Don't draw it, okay? Now we go on, write the positive element, which is the metal magnesium. That magnesium will receive the valence of oxygen, which is 2. It will receive it from oxygen. So let me just show you. Then you write the second element, which is the non-metal, the negative element. This oxygen will receive this 2 from magnesium as its atomicity. It will receive the valency of magnesium as its atomicity, while magnesium will receive the valency of oxygen as its atomicity. Now you see this plus and minus, please, please, and please. You do not show them. Don't write them here. They have no business here. The positive and negative is simply to give room for attraction, to tell us that these guys are going to attract. Of course, we know fundamental law of charges. Opposite charges attract, while like charges repel. So this is opposite charges. They will now attract so that they can come together and form the compound. Now observe something in this magnesium oxide. The atomicity of magnesium here is 2. The atomicity of oxygen here is 2. They are equal. They are equal. So you are allowed to do a little mathematics. As a matter of fact, you are meant to do that little mathematics. Divide the atomicities by their common term, by the highest common factor. So you see mathematics knowledge now, right? Now the atomicity of magnesium is 2. Atomicity of oxygen is 2. What is their highest common factor? The highest common factor is 2. So divide this by 2, you get 1. Divide this by 2, you get 1. Which means that magnesium becomes 1 in terms of atomicity, and then the atomicity of oxygen is 1. And you know that we do not show atomicities. We don't show atomicity of 1, rather. We do not show atomicity of 1, which means I'm going to write this and write this. So the idea is simple. Whenever the atomicities are the same, whenever the atomicities of the element that make up the compound in binary compound, right? If the atomicities are the same, don't show the atomicity. Which means in this case, I am going to wipe these 2 and wipe this 1 and this 2 as well. This is the correct chemical formula of magnesium oxide. And the reason is simple, because they have the same atomicity. So we conclude, therefore, magnesium oxide, that is chemical formula rather, chemical formula of magnesium oxide is MgO. Make sure you spend good time on this topic, this particular topic. If you give it a whole 1 week, if that is what it will take you to understand how to write correct chemical formula of a compound, then please give it that 1 week. Give it that 1 week. Don't play with this part of chemistry, please. Don't. Let's move on to number 4. Let us write the correct chemical formula of this compound called bauxite. That bauxite is aluminium oxide. So I will write aluminium oxide. Aluminium oxide. I don't even know whether aluminium is 1 L or double L. Should it be 1 L? Let me see. Aluminium. I don't know again. No, I'm sorry. Aluminium. This is serious. Forgotten the spelling of aluminium. See double L? Can someone tell us? Hold on. I'll have to check. It's not funny. Aluminium. Let me go to... I think it's 1 L, not double L. But let me just confirm. It has escaped. Quite funny, right? Aluminium. I think it's 1 L. Good. I got it. It's not double L. It's 1 L. I have to check it through dictionary. I have to check it through what? Dictionary. Don't laugh at me. It's not easy. It's not funny sometimes to bear all of this. But one good thing is I've got to check, to make research so that I'll give you the correct thing. There's a correct chemical formula of aluminium. So we move on and then, good teacher. Thank you very much for the commendation. Aluminium oxide, we have aluminium is there and then oxygen is there. So we move on, writing the correct chemical formula. How do we get it? Aluminium, the valency is 3 plus, and then oxygen, the valency is 2 minus. When they combine, they will interchange their valencies. The valencies will become the atomicities of the opposite element, right? That is to say that the valency of aluminium becomes the atomicity of oxygen, and the valency of oxygen becomes the atomicity of aluminium. You write the positive element first, aluminium, bring down the atomicity 2, which of course is the valency of oxygen. Look at it, something like this. And then you now write oxygen. Atomicity of oxygen will now be the valency of aluminium. You write it here. Now I'm going to ask you this question. AlO2. These atomicities 2 and 3, do they have a common factor that can divide? Do they? They don't have. The highest common factor of 2 and 3 is 1. And if it is 1, you cannot pull it out. Are you following, right? Just keep it aside. It means there is nothing to do here to simplify this, nothing else to do to simplify it. This is the correct chemical formula of aluminum oxide. Therefore, chemical formula of aluminium oxide is Al3, Al2, and then O3. Take note of that. Al3 and then what? O2. That's the correct chemical formula of aluminum. Let me check the network situation. And of course, all right. I hope you are following. Please, once you join this class, in fact, once you just look at it, whether you are joining the class fully or not, like what's happening here. What I am doing here is not something wrong. This is something that leads to nation development, because we have these platforms and then we laugh. But may that not make you forget another thing that is very important to you in your life as a student. So always stay tuned to dealing with binary compounds. Basically, this ammonium chloride. I've written green. This compound contains 3 elements, so it's actually meant to be a trinary compound. But why I brought it under this binary compound, because we are still dealing with binary compounds, how to write correct chemical formula of binary compounds. Why I brought this in under binary compound is because of the way the name of this compound is being pronounced. It follows the pattern of binary compounds. Look at it, ammonium chloride. The valency of ammonium is +1. The valency of chlorine, as usual, is -1. When they interchange their valencies, this is NH4. It's positive, guys, so you have to write it first. NH4. You don't show the ionic charge. You don't show it. You don't write that. Take notes. You don't. So you write your NH4. This NH4 will receive a valency of 1 from, will receive atomicity rather of 1 from the valency of chlorine. So like I said, let me still rewrite this again because it seems like network interfered. You will write ammonium, which is NH4. Normally, it is meant to be in brackets. Then you write the atomicity of this NH4 outside here. And the atomicity is the valency that chlorine is giving to that ammonium. Chlorine is giving it 1, valency of 1, you know. Now, this is meant to be in brackets because this valency of chlorine, which writes the atomicity of 1, you know that we don't show it. And saying not showing that atomicity of 1, no need of this 4. And then you combine it with chlorine. Chlorine is also receiving a valency of 1 from ammonium as its atomicity. But of course, you know, you don't need to show 1. You don't write it, so I'll wipe it. This is the correct chemical formula of ammonium chloride. Therefore, chemical formula of ammonium chloride is NH4Cl. Any other thing apart from this in terms of its atomicity, remember I told you atomicity is not your mate. Once you know the correct chemical formula of a compound, you don't touch the atomicity. That is how it's meant to be, wherever you see it. Number of molecules may change. You can have 1 molecule, you can have 2 molecules, you can have 3 molecules. Like all these things we are writing now are one molecule. Remember I told you I'm not going to talk about number of molecules in this class. I'm going to upload a pre-recorded video, maybe under the short section, YouTube short section of GMAETS for the Ones channel. Before next class on Wednesday, that is before next chemistry class, I'm going to upload that to show you how you get number of molecules. It's simple. It's just like somebody measuring, you know, a cup of rice can be considered 1 molecule of rice. Then you can have 2 cups of rice, 3 cups of rice, 4 cups of rice. Are you following? That's now 2 molecules, 3 molecules, and the rest of them. All the things I'm writing on the board, these chemical formulas we are writing, correct chemical formulas we are writing, are 1 molecules. So the molecule, number of molecules, they are your mates. You play with them however you want, depending on the quantity you are measuring. But you see this atomicity, these numbers written as subscripts, they are not your mate. You don't touch them. Scientists have established them by standard, and you have to know them that way. And the secret is from valence electron, which links up to valency, and then talking about this chemical formulae. Let us move on to number 6. How about we talk about the chemical formula of water? Water. Unfortunately, from that name, water, we cannot get the elements present there. However, take note, water is hydrogen oxide. Water is what? Hydrogen oxide. So it contains hydrogen and it contains oxygen. So let us get the correct chemical formula of water. You write your hydrogen with its valency and then oxygen with its valency. When they combine, they will interchange their valencies, and the valencies will become the atomicity of the other element. So write the positive element first, which is hydrogen. Hydrogen will receive the valency of oxygen as its atomicity. So I will step down 2 here because the valency of oxygen is 2 to become the atomicity of hydrogen. Then combine it with the negative element, which is oxygen. And of course, oxygen will receive a valency of 1 as its atomicity. And whenever I have valency of 1, you don't write it. Therefore, chemical formula of water is H2O. Nothing and nothing else. The chemical formula of water is always H2O, respecting the atomicity. You don't play with atomicity, for that guy is not your mate. It's a standard number that has been established scientifically based on the valencies of the elements that make up the compound. You do not play with valencies. This is the area where students find it so difficult to be able to handle correct chemical formula of a compound. Because, should I say, most of our students, anyway, let me just be kind enough. Some of our students don't know this concept of valencies, which will now help them to be able to withstand writing correct chemical formula. But here the GMAETS 41 is delivering this top-notch lesson tonight, and I hope you are learning. Please, make sure that you get a secret from valency, and to learn your valency, you have to get this idea of valence electron. Let us move on to ammonia. Please take note, this guy here is ammonium. It is an ion. It cannot exist on its own like this. Look at NH4. Nothing, no compound is like that. So we're not having like ammonium existing on its own that way. Or you writing it like this, say it exists on, no. It's an ion. Whenever you see them, they must combine with something else to form a compound. So we have this as ammonium. But here I am telling you that we are now going to deal with ammonia. Ammonia is a compound. It can exist alone. Ammonium, NH4, is not a compound. It can't exist on its own. It's an ion. So let's move on to read number 7. We are still dealing with binary compounds. Compounds that contain 2 elements. So ammonia. From the name ammonia, unfortunately, one cannot identify the elements present. But let me now tell you that ammonia is actually nitrogen hydride. Nitrogen and hydrogen. So nitrogen hydride, that is ammonia. But the hydride is actually trihydride, right? I really don't want to talk about the trihydride. From the correct chemical formula, you would find out that it is trihydride. So just know that ammonia is nitrogen hydride. It contains nitrogen and hydrogen. But this compound, there is one funny behavior of it that makes it a bit different from the pattern you write the other compounds, the other binary compounds you've seen. All other binary compounds you've seen so far, you write the positive element first, or the positive ion, as in the case of ammonium something, right? Ammonium chloride or the rest. But you see, in this case, it's different. What you would write first is not your positive guy. But there is a reason for that. I will tell you, right? Now, ammonia has 3 negative as its valency. It will combine with hydrogen, and hydrogen has positive 1. So, You notice that in this case, I wrote the negative guy first. So you have to take note of that, very important. So when it combines with this hydrogen, you're going to get nitrogen. The atomicity of this nitrogen here will be 1 because the valency of hydrogen is 1. Hydrogen will give it that valency as atomicity. Then you now combine it with a positive atom, which is hydrogen. And that hydrogen's atomicity will become the valency of nitrogen. This is ammonia, NH3. So this is the only exception per se that I can remember for now, where you would have to write the negative element first, nitrogen, before you write the positive atom. So you take note of that, please. Therefore, chemical formula of ammonia. Chemical formula of ammonia is NH3. Chemical formula of ammonia is what? NH3. Let us take carbon dioxide now as the last binary compound. Let's check the situation of the network here. And then we see. Okay. Number 8. Carbon dioxide. Carbon dioxide, or you call it carbon dioxide. Carbon dioxide. It contains carbon and oxygen. From the name, you can find out that. So what happens if they combine? How do you get the correct chemical formula of carbon dioxide or carbon dioxide? So it's going to be carbon. The valency of carbon is 4. Let's give it positive. And then it's going to combine with oxygen, 2 negative valency. When they combine, you write the positive guy first, carbon. It's going to receive the valency of oxygen as its atomicity. So we have 2 here. And then you write the negative atom, which is oxygen. Okay, and oxygen will receive the valency of carbon as its atomicity, 4. Now observe, you have atomicity of 2 for carbon, atomicity of 4 for oxygen. 2 and 4, they have highest common factor. The highest common factor is 2, so you have to reduce this by 2, reduce this by 2, since they have a HCF. Now, if you divide 2 by 2 here, you are going to get 1. Divide 4 by 2, you are going to get 2, which means this is actually C1O2. And you know, we don't show atomicity of 1. So I'll wipe this, and carbon dioxide, otherwise known as carbon dioxide, is CO2. Take note, whenever in the atomicity you have common term that can reduce, for binary compounds, you are expected to reduce them. For binary compounds. I don't think we've done something like that in trinary compound. I really don't think so yet. But like I said, please take note. For binary compound, let it be that this is for binary compound now. So carbon dioxide is CO2, also known as carbon dioxide. So we have been able to write correct chemical formula of binary compounds. You can think of another one. Okay, should we write that of hydrogen chloride? Hydrogen chloride, which we call hydrochloric acid. Okay, let's write that. Hydrogen chloride, or let me just write a hydrochloric acid. Now, anytime you hear acid in something, hydrogen must be there. Although you heard this as hydrochloric, but you can also call it hydrogen chloride. Whenever you are dealing with an acid, there must be hydrogen there. So this contains hydrogen and what? Chlorine. So as simple as when they combine hydrogen first, it combines with chlorine, the valence is negative, they will interchange their valences. Of course, the valence is going to be 1,1, so you have HCl. The correct chemical formula of hydrogen chloride is HCl. You can make the conclusion if you like, right? Okay, therefore, chemical formula of hydrochloric acid, hydrochloric acid, or hydrogen chloride, or hydrogen chloride is HCl. All right, I tried to just work on the network a bit to boost it and see. So like I said, we've been able to learn how to write correct chemical formula of what? Binary compounds. Compounds that contains two elements. And I hope you've learned something wonderful from this class. After this class, as we conclude it, you should no longer have any problem on how to write correct chemical formula of binary compounds. And like I said, you don't play with this because you need them to be able to flow in chemistry. In our next class, I'll be teaching you, that is next chemistry class, which is next week, Wednesday. I'll be teaching you how to write correct chemical formula of trinary compounds, compounds that contain three elements. However, take note that in our class today, we met one compound that contains three elements. That one that has that radical ammonium. But I had to bring it here. I have to bring it in this particular class because the way compounds with ammonium and any other non-metal, the way that compound is pronounced, follow binary system of naming compound, where you pronounce the first positive guy fully, and then the non-metal, which is negative, you pronounce the prefix, the beginning part, and then the end part, the suffix, you end it with "ide." So for example, we had something like ammonium chloride. Ammonium chloride. So that's the only compound where we had three elements in it. However, we considered it as binary compound because of the name. To write the correct chemical formula of a binary compound, first of all, you want to take note of the valency of the elements that make up that compound. Are you following right? So as we conclude this class, remember the things to bear in mind. You should have good knowledge of valence electrons. Not just good knowledge, rather an excellent knowledge even. An excellent knowledge of valence electrons will pull you through valency. Will pull you through what? Valency. And once you understand valency, then you can use that knowledge to write correct chemical formulae of compounds. Today we treated that of what? Binary compounds. We talked about what atomicity is, the number of atoms of each element in a compound. Like in this copper chloride now, we have one atom of copper and we have two atoms of what? Chlorine. In zinc oxide, we have one atom of zinc and one atom of what? Oxygen. In ammonium chloride, we have one atom of nitrogen, 4 atoms of hydrogen, 1 atom of chlorine. If I ask you the mole ratio now, in that case of ammonium chloride, it's going to be 1:4:1. Zinc oxide is 1:1, the ratio of the atomicity of the element. Copper chloride is 1:2. We dealt with other ones, like carbon 4 oxide is 1:2 also. Many more you saw. Aluminium oxide is 2:3. Magnesium oxide is 1:1. If I had given you something like magnesium chloride, it is going to be 1:2. Calcium chloride is 1:2, the atomicities. And I told you during the course of the class that you do not play with atomicities. They are not your mates. These guys are already standard because you get them from valency. Which means in writing correct chemical formula of a compound, you are expected to respect the atomicities of the element in the compound. You don't touch them. They are standard. That is how they are meant to be. If you already know the correct chemical formula. Whenever you are talking about balancing chemical reaction, for example, which we're going to treat on this platform as we're moving on in chemistry, you don't balance the atomicity. You don't touch it. Once you write the correct chemical formula of any compound, the atomicity is expected to be correct. What you balance is the number of molecules, which I said I am not going to talk about in this particular class. Now, we learned how to get the atomicities of the elements in the compound. We said that the atomicities are obtained from valency. What happens? Interchange of what? Valency. Interchange of what? Valency. If I am combining with you, You will give me your combining power. I will give you my combining power. Remember, combining power of an element is known as valency. So if I am combining with you, you give me your combining power, which is your valency. I'll give you my combining power, which is my valency. These valencies will now become atomicities. My valency will become your atomicity. Your valency will become my atomicity. That is why you don't play with valency, because atomicities of elements in a compound is simply obtained from what? Valency. And I told you where you write the atomicity of an element, it is written as a subscript, subscript. On the right hand side, just below the element, you can see like copper here is 1, chlorine here is 2, subscripts down here. Are you following? This one is 1, 1. And we also learned that if the atomicity of an element in a compound is 1, you don't show it. You don't show it. Take note of that. Make sure you study this part 3 of our valence electron, which is valency and chemical formulae. If you still have problems with how to get the valency of elements and radicals, please go back to part 2 of valence electrons on this platform under our live class section. The video is already available after our live class last week Wednesday. So take it so you can learn valency of our elements and valency of our radicals. Next week chemistry class on Wednesday by 8 p.m. or 8:30 p.m. Nigerian time, West African time. I'll be coming on live to teach you how to write correct chemical formulae of trinary compound tetrasulfate 6. How do you write it? You're asked to write calcium triazocarbonate 4. How do you write it? What about sodium triazonitrate 5? Now, next class, we are going to deal with that. You won't want to miss out in that class. So make sure you learn that of binary compounds, which we've just covered in this class. Now, next class, on Wednesday chemistry, I'll be dealing with that. If you are yet to subscribe, please kindly hit the subscription icon now. Subscribe right now, like right now, so you don't forget. After you subscribe, don't stop there. Go ahead and turn on the notification bell. Click on the notification bell. A menu will pop up. Select all. The reason, anytime I come on live, if I schedule a class, or if I upload any video pre-recorded, you will be personally notified firsthand by YouTube that something is available on GMAETS 41's platform. All right, share these videos to your friends, encourage them to join this channel, encourage them to subscribe, and let them also share the video to their friends. Like our videos, leave your comments of appreciation. Yes, leave your comment of appreciation. It's not easy. GMAETS is doing a lot. Yeah, so please, your comment of appreciation is welcome. And remember, as you like this video and you leave comments, right, you give YouTube the opportunity to share this video, to make it public, to make it go viral to other students, other scholars, because there are many out there who need what we are doing now. Many students are finding it so difficult to succeed in chemistry. And of course, generally sciences, but we need this because life itself is science. We need it because life itself is what? Science. Please, let us help to push this platform further. Let's push it out, let it go viral to many people who might be in need, and then we help them to be able to conquer this aspect of studies called science. Remember, on Friday, by 8 p.m. or 8:30 p.m., as the case might be, you'll receive the notification, definitely, if you have subscribed and turned on your notification bell, as well as select all. We have physics that Friday. We'll be dealing with the concept of vector quantities, of course. That's where we stopped. Then we treated the concept of parallelogram law of vectors. We are still going to look at further aspects of vectors in 2 dimensions, okay? And you want to make sure that you connect to the class. Thank you for being here. I will see you on Friday in our physics class. But don't forget, continuation of this chemistry class is going to be next week, Wednesday. Our timetable, as a reminder, Mondays, mathematics, 8 o'clock or 8:30 p.m. 8 or 8:30 p.m. On Wednesday, chemistry, 8 or 8:30 p.m. On Friday, physics, 8 or 8:30 p.m. Nigerian time, West African time. And our classes usually last for 1 hour 30 minutes at most. It might be less than 1 hour 30 minutes, as the case might be, right? But at most, 1 hour 30 minutes. Good night.